I thought we'd explore a really simple battery charger. So this particular one I think is actually, it might be the cheapest one you can find on Amazon. I think it was about $9. This is the charger. This is the box that it comes in. The listing is confusing, and so it does show that it's actually a AA, AAA, C, D, and 9-volt battery charger when it clearly is not going to even be able to fit a C or D cell inside of it, and doesn't have the terminals for 9 volts. So anyways, it is a AA and AAA battery charger. It says dual channel on the box, but the literature and the manual seem to indicate that it has independent cell monitoring. It does have battery status and a 5-7 slot design. Let's just take a look at the box here. And basically there's not that much that comes with it. It has a little manual, U-green, AA, AAA battery charger. A few things on the inside. Right here it says insert 1 to 4 pieces AA, AAA nickel metal hydride batteries into the battery charger according to battery polarity. So it does say right on here that you can do 1 through 4, not in pairs of 2. It basically has a very simple indication. It's blinking slowly when it's charging. The light goes solid when it's done charging and turns off when it doesn't have a battery in it. When the charging display lamp blinks rapidly, it indicates that there's a bad battery. I think that's pretty much it for the manual. So there's that. It did come in a little bag. Yeah, there is a USB to micro USB charge cable and a customer support card. Plug it in. What's a green branded cable? And plug it into I'm just going to plug it into a battery pack. The lights come on and they turn off. And we'll insert some batteries into it and then we'll get started. So it's pretty snug fit to get the batteries in. And you'll see them all start flashing. There you go. I'm only going to put 3 cells in for the moment. On the back, it shows what the current capacity is. It has this nice door too. I like the door is kind of a smoked plastic, so the lights aren't as bright. And you can still see the batteries through there. And so the input is 5 volts at 1.5 amps. The AA port output is, I believe this is the open circuit voltage, but it will try to get up to float up to 1.5 volts at 600 milliamps per cell. And then the AAA port is at 300 milliamps per cell. So it's a faster charger, but it's not super fast like that EBL one that I looked at a while ago that was up to 3.6 amps on a single cell, which was 6 times this. So it's pretty nice for these analoop cells or any other cells that are around a 2000 milliamp hour capacity, and you can charge them in maybe say 3 to 3.5 hours. If we do take a quick peek with the USB charger analyzer, what I want to do is just look at what power it's drawing as it's charging, as we remove batteries out. And we'll just do it for the 3 batteries that are in it. So you can see it's hanging around a peak of about 4.3 watts. And if I pull out one battery, that should drop. There we go, down to 2.75. And I'll pull out one more cell just to leave the one single cell in there. And it takes us down to about 1.1 watts. And the reason why I'm demonstrating this is that some chargers indicate that they have this 600 milliamp by 4. And what they really mean is that it is up to 2400 milliamps on a particular cell, or it cycles through the cells and actually hits them with that high amount of current per cell, which is really not great for nickel metal hydride cells. So this one does not do that. It divides up the current per channel to stay at that 600 milliamp charge current. But anyways, it individually controls each cell for charging and does a pretty good job with the negative delta V charge termination. I don't think it actually says that it's what it's using, but I think on the page it does, on the manufacturer's page. The only thing before I take it apart is, the only thing that I noticed that's kind of funky with it is that if you do load up this thing fully with cells, I'm going to grab one more, that it is a little difficult to get the cells back out again because the walls come up so high. I don't know if it's just easier for them to manufacture it, that way or what, but I find myself having to pry at it with something to get the cells back out. So in this case, I'm going to gently use my probe tip, and then once you just get one free, then you can get the remainder of them out. Come out fine. They're snugly held in there, and they have a nice, good separation in between them. And I am curious to find out is if they did mention temperature monitoring on the description, and I don't see any metal channel in here that cradles the body of the cell and detects the temperature off of that cell, as I've seen in other chargers. There's no screws. It looks like it is just snapped together, perhaps. This door also does not stay closed really well. So if you just, if it's upside down, if I hold it this way, you can see the door kind of swings open. So it doesn't really snap shut. But it is nice to have it, like I said before, closed on top of it when it's sitting like this. Why is there so much black crud coming off of this bag? Oh, it's falling apart. Oh, that's a bummer. Well, you're seeing black pieces of stuff on the, yeah, it's popping up a little bit there. The high definition is showing. It's like this bag, it's falling apart. And there's little crumblies that are coming out. Oh well. So let's see if I can pop the back of this off. Without stabbing myself. Don't really see how it goes together. There seems to be a seam here, a really tight seam. But it doesn't go all the way around. Maybe I can push this through the other side. Did not like that. There's a hole in the circuit board, it looks like, down through there. So I could try a screwdriver. My preference is to avoid using screwdrivers because it's kind of a one-way trip. You're going to leave some kind of mark on the enclosure, but it's a really inexpensive charger, so. Oh, that's a nice mark in the side. That's not going to work. This is really tightly fit together. The mold for this, wow, whoever did the molds on this is quite impressive because there is just no space to get anything in there. Well, I want to play around with it and see if I can get it open, and I'll come back. Okay, so this seems like it's going to be a one-way trip. This is the Gerber tool that I just carefully started prying into it with the knife, and I'm now kind of inside. Hopefully I'm not cutting up my board here. Does not seem to want to do anything. It is really held together. I'm pushing some of the spring terminals forward. I didn't really want to break it, but it's so firmly held together that I'm not really sure how else to get it open. If I push to the left, I'll just crack this whole back piece off. Well, not crack it off because it's part of the mold. The mold goes all the way around this way. So it looks like the whole top of this is like, well, except for the door. This is set in, and then the whole like tub where the batteries are sitting in is like one piece, and they put this back piece on. But this back piece does not want to come off. So I'm gonna keep the knife in there, and then perhaps just get the screwdriver. There we go. There's a lot of clips. The sound of plasticky crunching. Such a sometimes exciting and many times very nerve-wracking sound. I'm probably on the circuit board too, which might damage this thing, so we may not be able to use it once I get in there, but let me try to take the blade out. Close that up now that I got the corner off, and pull this open. My hands, yep, there we go. It's really clipped in there, jeez. That's impressive. Wow, there's just clips all the way around. You can see them, they're kind of small, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9 on each side, and I'm pretty sure I broke them all. Yep, they're glued. Oh, it's glued. Or was it like, what did they do? That's interesting. It definitely damaged it. I wonder if it's like heat. What do they call it? Plastic welding or something? Like they've actually done something to bond this to the inside of this. I don't know what it's called. Anyways, very clean back of a circuit board here. And let's even see if it turns on anymore. That seems fine. Not shorting out. No, 55 milliwatts. Waiting for me to put batteries in it. Cool. That's nice. Let's take the circuit board out. Held in by 2 screws. This is held in by screws. So how... I ask any of you out there that might know how the polymeric material and plastic stuff, like how would they seal this so that it would bond to the inside of this chassis when you can't get inside there? Just 2 screws holding it down. There's 2 boards. I see one board behind this one that looks like it's for the LEDs, and this one looks like it's for everything else. I'm going to be gentle. Try to lift this all out at once. A couple of test points. Actually, a lot of test points. Oh, cool. So there's a little header that connects to the LEDs and the USB port. Well, let's look at that one first. We'll put this off to the side for a moment. So let's take this little other screw out. And there's just a, oh, that's, ooh. Okay. Just to keep things into perspective here, but this board is very clean. Just look how clean that's really, let me get it a little closer. This is a $9 charger. $9. Very, very clean. No flux residue pretty much at all on both sides of the boards. But anyways, this is really cleanly done. Very nice. But then I just wanted to point out this one, the top board. Looks like it was hand soldered. There's a lot of gunk there. So I will be cleaning that off with some alcohol. There's a fuse right there on the input. That's really impressive. The pins go to each, I can see the pins on here running off to each of the LEDs. And then on the back side, there's 2 tracks that go off to the 4 LEDs. This might just be a simple little 5-volt regulator. In fact, we could just test it. So it's so the microcontroller is definitely controlling all of the LEDs. But let's just probe, let's get it in DC, and let's just see if we're gonna just use the connector body as the return path. And then we'll just check to see. Many of these should probably be no voltage because there's no LEDs that are turned on, but one of these is, oop. So it looks like it's passing 5 volts through there, but it's using the circuitry here. So I'm wondering if there's another voltage present, or is it just like a 3.3 volt rail? No. I'm looking at either side of that capacitor. Yeah. So this is just some sort of a regulator for, it looks like, perhaps stabilizing that 5 volt rail. So it's 5 volts through to this, and I'd imagine that the microcontroller and stuff and all that is 5 volts tolerant. Unfortunately, I've noticed already that microcontroller is completely been scrubbed, so there's no way to tell what the microcontroller is. But there are some cool features that we can talk about on this. So let me plug it back in. Let's do a quick check of short circuit protection. So dead short. Oops. Yeah, nothing. It doesn't even go. It doesn't even jump above. It's standby. A little higher. It doesn't blow the fuse. That's nice. It's a little fuse. Very cool. Oh, did it turn off? There we go. The battery pack turned off. The thing I like to see in battery chargers is that they put like a conductive spot, usually with some thermal compound between the bays, and they'll have 2 independent slots, 2 slots monitored by 1 NTC. Now what they did here is they used just plastic, and they have the NTCs just sitting kind of, it looks like it's kind of floating in between here. Maybe this tape kind of pushes it up in between, and then they use a tight fitting enclosure to make sure that the NTCs or the temperature sensors are sitting really close to the bays where the batteries are sitting so that there's a good representation between whatever the cell body temperature is and what these things are sensing. And it said on the listing that it had temperature protection, and it appears that it does. A good way to test this is just to go ahead and short the temperature sensor out, and if it does flash an error, then we know that it is actively sensing that. So we're going to go ahead and short this out. It doesn't seem to be doing anything, but you know what? It could be that it's not charging a battery. So let's put a battery in it so that it starts charging. And then I'm going to short out the sensor. I am shorting this out, and it is not picking it up. Not a great sign. I'm not getting through the flux. Maybe there's just a little bit of flux residue there. I don't know. It's magnet wire up to the temperature sensor. Oh, I think I hit it. Yep, it just stopped charging. Let's see if it does it again. It might just be, it might also be averaging, and then it sees it goes to 0, it stopped. Okay, so it's not blinking, but it just stopped charging. If I let go of it, because let's go and, so it's not going into like to a fault mode, but it's just going like, I'm not charging this battery anymore. Because if it's an NTC and I'm going to 0 ohms, that means the battery's super hot. Like really, really, really hot. And so what it's doing is, yeah, so you can see it's continuing to charge. I'll put these probes in impedance mode, and I'll measure the impedance across that NTC, and then we'll short them out. It's saying overload in mega ohms. That's weird. It could be that I could be shorting it now. Microcontroller is reading it. Let's do the voltage instead. Yeah, that could be what we need to do is voltage across it. I could just be shorting it out. So it's charging again. Let's get the voltage on here. Oops, negative 2.5. And if I just bridge it. Aha, immediately. Cool. It immediately stopped charging. Very nice. Okay, so I think I'm satisfied with that. So these sensors are actually measuring a temperature, they're reporting it back, and when that temperature goes to 0 ohm, which is basically a very high temperature, or the charging stops. So they're functioning NTCs. Anything else to show on this charger? I'm so happy we were able to get it open. And I didn't really destroy the enclosure that badly, so I can put it all back together again and reuse it. But this is a really nice little package for $9. And since we've got everything hanging out here in the open, let's just take one of the batteries. And I'm going to grab a piece of wire. And we're just going to check the current. I'm doing this test because there are other battery chargers, like I was saying earlier, that they don't pass current across all the channels evenly. They like select a channel and go sequentially and blast a channel with a ton of current, which is not great for batteries like Eneloops or other low self-discharge, higher capacity cells. The battery charger that I'm aware of that does this, that I'll be getting shortly, and be able to show that to you pretty soon. But here is the, let me just get all the screws out of the way so I don't short this thing out. And we'll just run this little test to wrap things up. So it's pretty close in the center there where the arrows are. Zero it out. Turn on the battery charger, put the battery in here, and then I will just hold this on the other side. See what we get. Is it actually starting to charge? Oh, it's not plugged in. Ha! Try that again. Oh, look at that. Beautiful. So you see it fluctuating because what's happening is it is switching off the charger and sampling the cell voltage to determine the negative delta V point and when it should charge terminate. But you can see you're right up at around 580 milliamp, which is very close to the 600 milliamp. That's really good. Yeah, I think that about wraps it up. This is a really cool little charger. Only gripe that I have with it is that the little door flaps a little bit. like I was showing before, and the batteries are a little difficult to get out when you have 4 of them inside here at once because they're really snugly held inside. Now that I know that there's temperature sensors down inside there and they use an all plastic design, I can see now why they wanted those batteries really tightly captured inside this enclosure so that if they do go into a high temperature situation, they will trip the temperature sensor and it'll stop charging. Very cool. Yeah, I would totally recommend this Ugreen AA AAA battery charger. I think it's running on Amazon right now for about $9. It's probably on eBay and AliExpress as well. And yeah, hope you enjoyed this video, and I will see you in the next one. Take care.